Good morning, everyone. On behalf of Bangalore Chamber of Industry and Commerce, we thanks your participation for this exclusive session. We also would like to acknowledge the support of Mr. Ayappan Ramamurthy and Mr. Shankar Narayan for accepting our invitation to address our members on the session on digital twin application of Industry 4.0 for multiple industry sector. This session is organized under the aegis of Industry 4.0 Expert Committee. The Expert Committee is headed by our Mr. Chandramouli, our past president, and he is the chairman, and co-chaired by Mr. Jagannathan from BFW M2 Next. Over to you, sir. Chandramouli, sir.
Thank you. This think part you take care because I'm getting all the messages.
Yes, sir.
I also disturb our speakers. Thank you so much, Rupa. I welcome all the participants and our two great speakers today from Siemens, Mr. Ayappan Ramamurthy and Mr. Shankar Narayanan. We'll continue to admit up to 11:30 because working days, so we are a little flexible. Today, I have the honor of welcoming the great speakers of Siemens. And as part of the Industry 4.0 publicity campaign that Bangalore Chamber of Commerce has undertaken since the month of May 2020, I only request Rupa to mute the other participants. There is an option called participants all mute. Rupa?
I have done it, sir.
You have to keep doing as people are getting admitted. That's a problem. Are you able to see my slide?
Yes, sir. Clear, sir.
Here we can.
Okay. We did some processing in opening the slides. A very, very brief introductory remark about Industry 4.0 for the first time audience today. It is a conglomerate of more than 10 technologies such as artificial intelligence, augmented reality, big data analytics, blockchain, digitalization, system integration, simulation solutions, additive manufacturing, cloud computing, robotics and automation, and industrial Internet of Things, and so on and so forth. The number of technologies are ever growing. There are more than 50 specific technologies and micro technologies which constitute what we call as a smart manufacturing solutions. And as we have in the context of social digitalization, such as our retail markets, digital markets, our Ola app, our Uber, Swiggy, Zomato, why not do in the manufacturing area also? The basic principle is to connect all the devices, people, materials, and products. To connect all of them, man, machine, material methods are connected through various system integration solutions, all coming under the banner of Industry 4.0. What is the reason for connecting them? That is to introduce to enhance traceability, which means when a product is being produced, you can trace all the background factors which go into the quality, productivity, and the lead time, throughput time, flexibility, etc. The traceability is extremely important. The root cause analysis, as we call it in quality management. The connectivity already mentioned to you. And above all, the visibility. A real-time visibility is enhanced by these technologies. We are not looking at reports coming from yesterday or the last week or the 1 hour before. We are looking at reports coming on a minute-to-minute basis and with a 10 millisecond of latency, as we call it. And therefore, visibility of the operation is very clear. And through the various mechanisms, the visibility is taken to across the levels of the organization, starting from the shop floor to the top floor and across the functions. Anything happening in a manufacturing function is visible to the design function or vice versa. And anything happening to the design function is visible to the after-sales service function or vice versa. That means through a product lifecycle management, about which Mr. Shankar Narayanan will talk today. And above all, the mobility, the mobile phones, the devices have increased from 1 million 10 years back to 50 billion is projected now. The number of devices. The devices could be a mobile phone, an iPad, or it could be a laptop connected to internet. And all of them are connected on real-time basis. So the data is flowing all the time. And the benefits are many, many. I don't want to dwell on it. The safety, quality, productivity, cost, uptime, delivery, cycle time, flexibility, All those benefits we talk in terms of lean manufacturing, operational excellence are accrued through this Industry 4.0 technologies. And without those benefits, these technologies have no value for the customer or for the manufacturing organization. And another day, I will talk about the data analytics, the descriptive data analytics, the diagnostic data analytics, predictive data analytics, prescriptive data analytics. We will ask an expert to come over to Bangalore Chamber online webinar and talk about data analytics as a specific subject. I think Rupa is making a note. And the 4 industrial revolutions, starting with mechanical engineering to electrical engineering to electronics and communication and leading to computerization and internet era, are considered as a 4 industrial revolutions over a period of last 100 years of 300 years of industrialization in the world, as it were. And the customized manufacturing is now in the last 10 years. The customized manufacturing means everybody is looking for a different product, different specifications in any sector. And today, Mr. Ayyappan, who is a director of the Siemens software and PLM division, he is going to handle multiple sector examples. And Shankar Narayanan, he is going to talk about digital twin as it applies to aerospace sector specifically. I've also invited our co-council, which is called the Aerospace Skill Council, and many of them are listening today. And as I am talking in the introductory, many more people are joining. And it's a working day, so we accept some flexibility. Organizations are reimagining the manufacturing space. When I say manufacturing, it is not only the shop floor, it is a complete product life cycle, starting with design to after sales service, with a closed loop of every function back to the previous functions. And this manufacturing domain could be from any sector, starting with FMCG, cosmetics, detergents, food and beverage on the one hand, to aerospace, machine tool, and so on and so forth on the other hand, with automobile industry falling somewhere in between in the spectrum. And thanks to Corona, multiple sectors had different impact by the Corona. All of them are recovering at different pace, at different timings. And hopefully, the digital twin is also enabling the adoption of the Industry 4.0 technologies. As we go along, Ayyappan will explain that. And it is a virtual representation of the physical product or process on the one hand, and on the other hand, through a virtual reality, as we call it. And both simultaneously coexisting with what we call the cyber physical systems. And simulation is part and parcel of it. And the case studies are universal across several sectors, as I mentioned earlier. Dr. Ayyappan, I call him doctor because he's almost like that when he speaks. He's a technical director of Siemens Industry Software, a business unit of Siemens Digital Industry Division. They don't call it as anymore as factory, they just call it as digital factory. I visited the Kalwa factory in Mumbai. The factory itself is called digital factory. Anything happening in the shop floor and other functions in that factory is going through a digital transformation at a very high pace. With 25 years of experience in all these areas like PLM, digital manufacturing, and who can be better than Ayyappan to talk today? It's an online webinar and he's also working at a home and digitally enabled. And Siemens, they are also considering working at a home as a very powerful mechanism, not only to spread the training and knowledge across industries, but also to guide their own workmen across the factories. And Mr. Ayyappan has published several articles and he has been heading the Asia Pacific region prior to this role for the digital manufacturing portfolio. And he worked in Bajaj Auto Pune before the Siemens era, Siemens career. Shankar Narayanan is a good friend of mine. I know him from the machine tool days when the Siemens SINUMERIK CNC control system were supplied by him and supported by him. Today he is wearing several hats. He is not in charge of the SINUMERIK division. He is in charge of the Peenya Center of Excellence for Digital Manufacturing. There is a Center of Excellence in Peenya. All of us should visit that once the Corona is behind us. And he is also looking after the business development for the aerospace sector. He has overall 20 years plus experience in the field of machine tools and engineering. And I welcome Mr. Shankar Narayanan. He will share with us the digital twin for the aerospace sector. With those remarks, I would like to hand over to Mr. Ayyappan, and Ayyappan will then do the time management and hand over to Mr. Shankar Narayanan. And then we will have a Q&A session where we will welcome. But the participants can start posting their questions in the respective text box now itself, starting now. till that 12:30. Till 12:30, you can start putting your questions, and from 12:30 onwards, we will undertake the Q&A, and we will try to cover as many questions as possible up to 1 o'clock. Thank you so much, Rupa. Thank you, Mr. Ayappan. Thank you, Mr. Shankar Narayan. Over to Mr. Ayappan. Thank you. More people are joining. We'll allow them till 11:30, and then we will see whether we should close the admission or not. Thank you, Rupa.
Thank you, sir. Thank you so much for the fantastic introduction. And as you mentioned, there is a lot of change which has happened last few years. Industry 4.0 driving a lot of changes. What has happened in the last few months is gone through a high level of acceleration. And if I could pick one changes which has happened is the shifting of customer loyalty. So shifting of customer loyalty, we have, all of us have done it or experienced. Now the way, either you buy a grocery or, we go to the hotel and attend, event. So there is the loyalty has shifted the way we want to look at either buy things, use things, or, evaluate options. Everything has changed. Now, that is impacting us, from the business side of it, from the industry side of it. First, we look at, is the price competitive? How is the quality? But more importantly, is it available? Is it available online? So first point is checking through the internet medium, and then compare the prices, compare the feedback. Now it's become so important that if you want to. We want to survive, we want to win this new world, then you have to look at the changes which are happening there and how we can reimagine ourselves as businesses, as industry, to look at to look at conquering the future, if I could put it that way. But this has increased the level of complexity very high, and this complexity is because of the products, because of the personalization which has happened, the kind of flexibility that needs to be addressed in the manufacturing environment. You need to have a connected product which is collaborative, which is intelligent, smart, and all this at a point where it should be at the best possible price, world-class quality. And all the more important is whether it is available at that point in time where you want to use it. So this has put huge amount of challenges for us, and key to act is the digitalization. So the digitalization, there are several technologies Mr. Chandramouli mentioned. How do you look at leveraging these technologies, and what can be done either with 5G or generative design, future of automation, edge computing, AR and VR, big data analytics. Now, what are these technologies? How we can reimagine our design, our manufacturing process, our customer service, acquisition of customers, service, after service related areas. How do we evaluate all these options with digitalization in place is a key question. And to look at it, we look at it at this event from a digital twin perspective. So you have the physical, the real world, and how do you virtualize this real world scenario, either a product or a machine or a process, or the
Ayappan, we couldn't hear. I think some issue with the internet. Ayappan, you are on mute.
muted actually. Can you unmute me, please? I think I'm being muted. Hello?
Now you're audible.
Oh, because I unmuted and probably it is muting. Let me. You're able to see my screen?
Yes.
Okay. So the key aspect of it is how do you creating the digital twin of the real world, where we are able to connect. The digital is continuously in touch with the real world to look at to gather the performance data, change itself to mimic the real world behavior. And once you have it, you're able to simulate it, optimize it, and make the changes into the real world. So that's basically look at how look at a digital twin at a concept. Now, this can be expanded across to three main aspects of the digital enterprise, if I could put it that way. So one is the digital twin of a product, how close we can mimic the real world product in its completeness. So whether you're looking at the geometry, the shape of the product, the durability, how the product is going to perform in real world at various conditions, and evaluate the performance of the product. And second stage is the digital twin of production. So here how you look at how we are going to manufacture this products. So what are the processes, what activities, what toolings, fixtures, gauges, how the automation and robotics are going to be used, how the people who are going to work are going to work along with these machines and equipments. And the third stage is what we call as the digital twin of performance, where we meet the real world. So in the real world, in terms of one inside the factory, and another is the products being available at the consumer, and he is using the products as well. So here look at the automation side, the PLCs, the networks, several other civil, mechanical, electrical equipments which are there, which goes into the plant and machinery. And finally, how these products are getting used at the final end customer status, either it is a machine or consumer product, several aspects of it. So broadly, digital twin, if you look at from a manufacturing standpoint, digital twin of a product, digital twin of a production, and the digital twin of a performance from both the plant aspect of it as well as a product aspect of it, where you're able to run this across through a continuous digital loop, where the virtual is connected to the physical. From the physical, the operations and the parameters are captured to mature and mimic the reality. And in the virtual, where you're able to optimize it and further push it across to the real world, where there is a continuous improvement from the manufacturing as well as the product standpoint. And this could be applied across various industry verticals. We look at some of these, or a lot of these industry verticals you mentioned, right from the aerospace, defense, consumer products. We'll also look at some of our experience with the pharma and medical devices, specifically on the COVID area, how paperless manufacturing we are enabling to one of the customer, one of the industries who are providing the medicines, vaccines for COVID, and also in the areas of energy, utilities, food and beverage, machinery, equipment, electronics, semiconductor. So wide variety of areas how digital twin can enable the future, where you can use the digital twin to reimagine the future of design and manufacturing. So first we look at digital twin of the product. So by and large, if I can divide into major scenarios of the product. So how do you conceptualize the product? So product needs to be smart. So which means smartness comes from the sensors and electronics and the software which goes inside, along with the aesthetics and the mechanical aspects of it. So how do you put all this together and simulate the scenario, and then take this across into industrial design, creating the smart product? You also look at the generative design and the electronics and electrical aspects of it, and also conclude with the reverse engineering from a product design standpoint. Let's start with the systems engineering. So at the concept level, you call it as 1D simulation. So where you are able to use the mathematical equations to connect across the systems or model-based systems engineering behavior. The example can be a machinery, or in this case it is an automotive, where there is a combination of motion, chassis, hydraulics, gearbox, engine, brakes, steering systems, so on and so forth, and at the concept level, what kind of performance you are looking at, and what kind of dimensioning that you need to create at from the product level, which needs to be multi-discipline. You can also do a model in loop where at the concept level how the product is going to perform can actually connect with the hardware or the software to evaluate, to take early decisions before moving across into the product design. And once you have the concepts ready, the system engineering concepts are available, you can go into the industrial design aspect of it. You can have a background, it can be a sketch where you can do it on a pad, or as easy as what you can see, taking across like a virtual clay, where you are able to easily subdivide these models or surfaces to give a shape that you would like to create it. Background can have some of the hand sketches or concept sketches, or directly you can do that inside the software. Now here I would like to create a drone. So at a broad level, I would like to have the shape looking like this. Then I can actually mature this shape. What you can do is connect with your engineering software to look at the CFD performance, the durability, the noise and vibration performance of it to mature, to get these concepts more practical. It can be applied across. Earlier it could be a drone, or in this case I am creating a handrail, reciprocating handrail. Now you can see with the background sketch I have created, you could use these sketch, use the similar kind of modeling methodology, which is as easy. So it's not really trying to learn several years to create to design the software, but you could see that in background of a sketch you are able to create and create the models, 3D models, evaluate different kind of options what you want to look at from an aesthetics standpoint, surface design and modeling standpoint. And what you could also do is once you have some of this geometry created, to do an assembly to look at how the product is going to look like, and also evaluate the performance aspect of it. Now you can see that there is additional engineering in addition to the broad aesthetics of industrial design, which we have created at the early stage. Now going into the industrial design, you look at the mechanical performance, you look at thermal performance of its strength, noise, vibration, harshness. Now you're able to evaluate how the product is going to perform in the real world digitally. So you can optimize the performance at the early stage. And it could be, we looked at a drone, we looked at a consumer product like a reciprocating saw. Now it could be a machine tool where you have, there is complexity, high level of complexity with automation, sensors, controllers. You have, the hydraulics and pneumatics working together. Now the physics of what speed the conveyor should move, whether you really need a fixture or a holder to do this, what kind of acceleration and deceleration this conveyor could handle while working across. So this machine is actually fixing a bottle cap. Now how I can simulate it digitally. So I'm able to virtually design and validate this product across, and also do a commissioning. So when you say do a commissioning, so you have the controller, you can see on the bottom right, where you see the controller. So you are able to virtually validate, virtually commission these machines. So you're able to get a much more optimal design, and able to bring these products faster, cheaper, and at a high level of profitability than the conventional way of manufacturing, designing and manufacturing things. Now I can go further on the smart products and smart design. Now what is happening here is the ability to create a bionic design. So now you can see the flower bulb which is there on the left hand side. So what is the flower bulb doing here? In one of our factories, where there is a burner, which is actually going into the combustion chamber. Now the size and the durability and reliability of this product is very complex, because the temperature it needs to sustain itself is about 1300 degrees Celsius. Now you can imagine that most of the metal which is going to handle this itself is its melting point itself is much lower than this value. Now the level of performance, the level of cooling performance need to be so high that it needs to meet this kind of performance criteria. And now what you're able to do with this panel bulb design is ability to create a generative design. So which means you're able to get inspiration from this, use the optimization techniques and generative modeling to have constraints. And you see on the right hand side, which is the cut section, and you can see that how the additive can be used to manufacture this kind of scenario. But what we are able to do with the generative design is ability to bring out products which earlier was really not possible, or we could not be imagined. Earlier used to imagine the kind of like cylinders, rectangles and prisms and blocks, but imagining this kind of a shape was really next to impossible. Now with the generative design, you're able to create this kind of designs. The performance level that could be achieved is probably twice or thrice, and the level of speed at which you're able to manufacture, the reliability, this could be the earlier the design was about 8 to 10 parts need to work together, again creating a problem of reliability. Now you're able to do that in a single go, which increases the reliability, as well as the size that what you're able to achieve is probably less than half of the earlier design. So there's a huge amount of improvement and change which you're able to bring with the generative design in place. And next we see where for making the smart product, you need to have a combination of electrical and electronics working together. And again, Siemens has the unique advantage of bringing both the capability from the Mentor product suite, where you have the electronics design and the mechanical design from the NX product suite working together to create a holistic smart product, and not just a mechanical product, and the electronics and the automation works in isolation, which is again a important aspect where you need to work together. You need to integrate, have an integrated product development if you want to reach that level of improvements. Next, what we are looking at is, along with that, there might be a need for bringing in the reverse engineering aspect of it, where you can bring the scan data. Can I bring a part and take it across and manufacture, make some changes and do it? Today it is possible through the technology what Siemens introduced is called the convergent technology. For several years, the reverse engineering aspect is there. Now what earlier used to do is to bring these point cloud and do a remaster, which means create a surface solid out of it, which is a tedious task. What we are able to do now with the convergent technology is to bring the scan point cloud, and the convergent technology helps us to directly work on this point cloud, make some changes, modifications, and work to have a hybrid environment of point cloud, surfaces, and solids. And that actually is becoming a game changer. And game changer, for example, on the right hand side, you see implant. So this implant is taken from, for a knee surgery. So there is the scan data coming in out from the MRI or a CT scan. Now you can create an implant as close as possible, which actually can make a huge change for the patient who needs to get through this. Otherwise, imagine that what goes inside the body. Now imagine that if it is not very accurate, then it is going to create a huge problem. Now with this convergent technology, you are able to bring out these changes. And just to have a case in point, where Zipline, one of the Siemens customers, able to use these technologies, whatever we saw earlier, both electrical, electronics putting together to create a drone. And what they are able to do is help the people in some of the villages in Rwanda, where getting to these specific villages takes 6 to 8 hours, and getting the hospital supplies in case of emergency or a pregnancy, those kind of scenarios are very complex because you need to have the blood supplies as well as medicines at the right time. What they are able to do is use the drone which they have created, and able to bring this product well, able to validate it digitally, and able to bring this innovation to create actually a huge change in life of the people who are there in Rwanda. Now, moving in from the digital twin of product to digital twin of production, where we look at some of these areas where can we simulate the complete manufacturing. Earlier, we say that can we simulate or can we create a digital twin of the product. Now we look at how are you going to manufacture this? Can we run this complete plant digitally? Can we evaluate and look at the energy operations? Can we do the offline programming? How do you connect across the machines? How do we look at optimizing the operator performance? Can we predict the build quality before we actually physically produce at the shop floor? So some of these questions we see that. First, the ability to look at production simulation. So here, example from Bangalore, Sansera Engineering. What they're able to achieve is able to completely simulate the complete plant production, right from the stage where the parts coming inside the factory, moving across through various cleaning, drying activities into several machining stages, what kind of batch sizes, setup changes need to be done, going through the forging, heat treatment, assembly, multiple other processes. Now, I'm running this plant first is look at either a green field or a brown field, ability to create a simulation which is actually running as per the current scenario. And second is to look at the optimization. Now, once they have built this model, which is accurately representing the current scenario, now they are able to optimize, and what they were able to achieve is a 30% improvement in their manpower productivity, which means whatever they were actually doing with the same level, they were able to do with 30% less manpower, where they are able to use them for the additional plant expansion and other activities. So you can see that it's not 1 or 2% improvement, but a very, very significant level of improvement what they were able to achieve with the production simulation. From Sansera and Bangalore, we look at Electrolux in Europe, where they have about more than 50 factories across the globe. And the product changes are very high. Introducing the product change is one of their key competitive advantage. And how do you get that faster? How do we ensure that you have a first time right? Because the market window, the differentiation time is so short. Now you have to capture the market as fast as possible. And the option what they have chosen is to look at the digital factory. So they created the digital factory so that the introduction of product happens digitally first, and which they are able to achieve an improvement of 30% improvement from the time to market aspect of it. And the other side of benefits is also cost savings in terms of ability to do that, avoiding investments which actually not directly impacting. You could optimize the existing operation to leverage, to maximize the capacity that what they already have. Moving further into a factory, BMW, what you're able to achieve in one of the lines, again, all these are public case studies. You can have additional information on each of this. With the plant production simulation, what on a building line, what they're able to look at is can we minimize the overall energy consumed while it should not call for an additional or capital investment. So ability to simulate it and taking in the energy consumption of the areas. Now, what are the options they could evaluate for optimizing the energy? They were able to save in one single line that they are able to reduce about 3 million kilowatt hour of the energy consumed per year. So now they have at least more than 50 lines across the globe. Imagine the kind of potential that of savings which could go in from from this specific building line itself. And of course, it could be expanded across to all other areas in this plant. But here where they are exactly seeing the kind of benefits what they are able to achieve, not only in terms of cost, but also becoming green and polluting less into the environment. Again, additional benefit in addition to the cost savings that which goes inside. Now there are additional, there is a lot of emphasis on human and robot working together and able to have a cobot and cobot having a machine-to-machine communication where you see the ability to work both robots working together. More we call it as a cooperative robot. To look at possibilities which were not possible earlier. And another aspect of it is, how do we create a self-learning robot? So you have the algorithms and rather than one doing an offline programming of it, can it automatically learn and can we do a guided teaching to improve the level of productivity and accuracy? And can we commission this factory digitally? So you have the plant, you make the changes in the plant, or creating a green plant or a brownfield activity. Now, how well you're able to run this plant digitally is through virtual commissioning. So virtual commissioning either through a hardware in loop or a software in loop scenario. As you can see here is the hardware in loop, where the physical automation, so in this case SINUMERIK, where it's controlling the digital factory along with the robots, the machines working together. You're able to directly control either the gate opening, the emergency, or the scenarios of product changes, cycle time changes, so on and so forth. The ability to do that. Not limited to automation and robots. How do you bring the human aspect of it for the health and safety, and the performance of the operators? And to emphasize further, so for example, the India's anthropometric data published by NID Ahmedabad has been incorporated inside the ergonomics software, in this case the Technomatics software, where you're able to analyze for NIOSH, OS, fatigue, multiple other ergonomic analysis, so that how well you can actually improve the shop floor performance of the operators can be simulated, validated, and improved through the digital manufacturing solutions. Another important aspect is you're able to plan, validate. Now, can you also build the product? Can we look at what kind of reliability, what kind of quality that the products which are going to come out of the factory will be when through the simulation? So in this case, you've taken an example where you would like to actually digitally build through the GD&T. So you have the geometric dimensioning and tolerancing and the which are there. You can take that as an input and using the simulation. So we use Monte Carlo simulation and high-low median simulation to simulate the performance. And what you're able to do is ability to build. So either it is 1,000 production quantity of 1,000, 10,500, or even one machine you're going to build. Now you're able to use the simulation to, if the parts are built according to the individual tolerances, if I'm going to assemble it with the sequence and the processes that I'm going to follow, which means either it's a fixture or the kind of locators that I'm going to have, what will be the build quality? This is the predictive build quality. Now, what you can do is what we have done in one of the customers is connected to the shop floor, where the shop floor information of all these quality are bringing back and feeding the predictive scenario. So what you're able to achieve is a continuous improvement in quality. So you have field information. Most of the quality data is going into some books, either physical or digital, but most of the times, not much use of the quality information is there. Now with the digital twin, where you're able to use the quality information from the shop floor, ability to make a evaluation through the predictive and run through a continuous improvement, which actually goes into a world-class, building world-class quality products. Moving on from digital twin of production to digital twin of performance. So we look at how do we execute. So we planned, we created the product, we did the manufacturing planning or the digital manufacturing. Now, how do we execute the products into the shop floor? And then if the products which are there in the field, can we do a remote monitoring? Can we have a connected twin of the plant and machinery? How we can use augment reality and fleet management inside. So first, let's start with BioNTech. So BioNTech is the collaborator for Pfizer, who was successful in the process of bringing the COVID-19 vaccine. And what we are able to help BioNTech is to create a paperless factory. So to create a paperless factory in terms of the R&D process, the execution stages in the shop floor. So you have the right data available, and earlier in the introduction, Mr. Chandramouli mentioned, how do you have the visibility, traceability, and the performance of the factory digitally available? So that is something which you're able to work through BioNTech. And on the another scenario where this is Renom in Pune managing the windmills across several states. Now, ability to, how do you ensure there is a high level of asset availability while reducing cost? So you are able to simulate, you are able to bring the data, you are able to evaluate for the further performance of it, because here you have a scenario where the blade may last for 20 years, but the gearbox may work for 3 years, and you may have a bearing which may be there for 2 years. So, so the windmill as a whole, there are multiple points of failure. So any one failure, it could actually have a downtime of the overall cost performance and the business performance from the individual, and also from a power availability aspect of it. So how do you bring this scenario digitally is what Renom is doing. Now you're able to bring the factory connected. So earlier at the windmills, now you can have the real plant, connected plant, which has a connection with the digital plant. So you have the plant level, line level, station level, cell level, so on and so forth. But each of it has a connection to the physical aspects of it, where the information of these plant machinery, how it is working across, how the historical performance has been, the FMEAs of the machines and equipments, what level of productivity that these machines are doing, and also looking at the asset performance and looking at the historical data and bringing it to the level where you have the manufacturing intelligence and using the data analytics aspect of it. One example which we saw in one of our factory in Hamburg is the PCB cutting machine. As you can see, this machine is cutting the PCB, and when you cut this, there is a lot of dust which comes across, and this dust gets into the spindle, and after several hours of continuous work, months and days, this dust gets accumulated and there is a failure. Now, how to predict that, when, at what level you have to maintain it, and how do you ensure that there is no sudden stoppage of this machine happens, because then again it's a downtime and there is a productivity loss and so on and so forth. So if you look at here, what we have done is put the edge device, so either IoT 2040 or a Nano from Siemens, along with what you call as the anomaly detection. So the machine intelligence, which actually trains across. So it identifies that before the failure occurs, there is an increase in the current which is consumed, as well as there is a speed reduction which is happening, and which is through this data analytics. And what you're able to do this with the algorithm is able to predict failure 100%. So predict this 100% and 2 days in advance, and 100% of the time, and that becomes a a significant saving for the machines that which are able to run into that factory. Now, this could move across. This could be one individual machine, it could be fleet of machine. Maybe you have the machines supplied across to various geographies. So how do you look at remote monitoring, remote management, higher availability through the connected machine scenario? So that's basically what you will be able to promise to the customer in terms of higher availability, higher service, and so on. And next aspect of it is how do you bring these across into a closed loop scenario? So how do we connect the plant information, the machine information into a simulation model? That's something that of a huge opportunity potential to do this improvement. So in this case, is a bottling factory. So in the bottling factory, where you have the simulation model, creating the digital twin of the bottling plant. And this is connected across through MindSphere. MindSphere is Siemens IoT platform, and where this is actually connected across to the real world with the physical machines. Now, with the physical machines coming inside, as you can see, the machines which are connected from the shop floor, producing at the levels that has been designed for. Now you're able to bring that and mimic the performance of the real world performance into the simulation model. So there is a plugin or adapter from MindSphere to the production simulation scenario. So what Siemens has uniquely done is merge the simulation with the IoT performance of it. So bringing in the data from the MindSphere through the cloud, and what we have done, what you're seeing, the simulation is actually the real-time simulation where the shop floor data is brought and you're able to run this simulation model more or less on a real-time basis. So this feeding of the field data into the simulation performance of it and taking it for the optimization aspects. Now, the other side of it is also using the AR and VR. So with Hickory, the head-mounted device, for plant operations, what you're able to do with the plant operations is, use the expertise available at central location and the plants which are at various geography, which may be there, and is to actually make changes, perform the maintenance and service aspect of it. So as you could see, with the head-mounted device on the DACRE, which is there, now you can connect across. Now you can see that how the AR is able to help the probably a novice operator to look at what kind of performance, what kind of activity he needs to perform, while the expert happens, can be there remotely, or it could be through a guided operations, which as what you can see right now. And this could be also extended across to a connected fleet, where here, there is several other examples you could see. So in this case, as the consumer of this, which is hiring this particular vehicle and taking it across, what kind of persona and what distances this person travels, the experience of it, the acceleration, deceleration, and if there are performance aspect of it, how do you charge it, how do you have a new level of business coming in across from the personalized vehicle to an electric autonomous vehicle. So yeah, this is done by Oli, which is running in the state of Michigan, where you're able to connect the fleet and take this information of how many people are traveling, the time they stay inside, how many people stay at what duration of time. Look at various aspects of it. Because of the autonomous nature, there is a high level of heat which goes into the braking. Now, how do you optimize the performance of the HVAC, performance of the braking? There is high level of performance related issue in terms of braking. How do you evaluate all these performances? Now, to look at holistically, we look at the digital enterprise and the digital twin from a product, digital twin of production, and the digital twin of performance, and to use the digital twin to reimagine the design and manufacturing and service aspect of it. And from Siemens, you have a complete portfolio. As you can see on the top, you have the MindSphere, which actually brings the field data into the digital twin of product and production, and the simulation design and simulation softwares from geometry design, PCB design, electrical, electronics, wire harness, PCB manufacturing, and the line automation portfolio or manufacturing operations management portfolio, and finally connecting across with the asset performance and the digital lifecycle service aspect of it. And all these are connected through the team center, commerce, and plant side, which is the forward side of it, the improvements side of it, powered through Team Center, Commerce, and Plant side. The feedback side of it, enabled through MindSphere scenario. So the summary is what we see. There is a loss of customer loyalty and the emergence of high level of complexity, personalization, connected vehicle, smart vehicle scenario. And to do that, digital twin is key aspect to treat it as a competitive differentiator, and reimagine the design and manufacturing, which can be applied across to multiple verticals, and the digital twin of product and production and the performance, enabling the digital enterprise to happen. So that's the summary, and I would like to invite my colleague Shankar to take it across from the digital twin for the aerospace industry. Shankar.
Yeah, thanks, Ayyappan. Ayyappan, can I share the screen if you don't mind?
The screen. I just left it at the same level so that you're able to take it.
Thanks a lot.
Ayyappan, in the meanwhile, Ayyappan, I request you to just go through the questions in the text box.
Okay.
So that you can formulate your thought. No need to answer in the text box.
No problem.
Without any delay, you can start the answers as soon as Shankar. I don't know how long Shankar needs.
I'll try to wind up by 30 minutes.
Great, Shankar.
Yeah.
Excellent time management.
We'll maintain the time.
Thank
Yeah, thanks a lot. So thanks, Ayyappan, for setting up the tone on the digital twin area. My voice is echoing. I'm the only one feeling it.
Yes, we are able to hear you loud and clear.
Oh, okay, thank you.
You can speak a little louder so that very energetic.
Yeah, thanks a lot, sir, for mentioning that. I will try to make it up. Digital twin in aerospace industry. First of all, thanks, Ayyappan, for connecting to start up with the digital twin, giving the audience a very clear picture about digital twin of a product, production, and also on the performance side. I'm going to take it across only on those 3 points what Ayyappan has mentioned, which is predominantly the area where digital twin is being compared with the real situation. I'm going to talk about on the aerospace area where we consider an aircraft as a product and also the n number of individual components which goes into the aircraft manufacturing. Let me start further. We're going to talk about on the three part of the aircraft production, engine production, aerostructure production, and on the final assembly area. Though there are a lot of other areas are present in the aircraft manufacturing, today's presentation would be based on this 3 topics: engine production, aerostructure production, final assembly, and the relative technologies. What is it required? Digital twin, is it only on the design area? Can it also be on the production? There is a question on the mind asking about why only in the production, but can it be also on the assembly area? So I'm going to address these points. And I'm also going to talk about the devices which is used in this manufacturing environment, which is going to predominantly support the digital twin in the production as well as in the performance. So that becomes an easy tool for us to also in the later stage to do an analysis with the data what is being derived out of each and every process in the manufacturing. So this is the overall concept what I wanted to show it across. So the digital twin of a product, consider an engine of an aircraft as a typical product. Digital twin of a production, manufacturing of a engine component, typically the blade, the compressor blades, and also the individual components used in the engine manufacturing. And lastly, on the digital twin of the performance, you compare the data, what you are preparing it in the master data for a production environment, which is on a simulated platform. And also you are validating, verifying, validating the production area, and also checking on the performance part. Right from the initial product design, where you define the specification, and you also define the materials. Then goes on to the process area, where you have to look on to the process optimization of your manufacturing, the infrastructure requirement of your production, the individual components required to set up your infrastructure, and can that be onto a simulated platform. So these things are going to be on a common platform, and this common platform, which is integrating all three digital twin of product production and performance, is going to be on the team center area. um, Team Center is a base platform which handshakes the different departments in the production environment, right from the design department, the planning and the engineering department, and also to the production area. So all the departments are interlinked. The data is getting exchanged from one department to the other department, and the data optimization is also happening at various levels, be it the stage level 0, 1, 2, or 3. Any stage levels, the data can be accessed and can also be optimized based on the requirements and relative to the practical modifications which is done on the production area. So all these things are going to be together and also being working with the exchange of data information. Lastly, on the product performance or on the performance area, uh, an engine as a product, once it is completely assembled, and then it has to deliver the results as it is desired to. In order to monitor that, quite a lot of external devices which is also fitting into the engine, be it thermal temperature sensors, or you can also see on various other monitoring area where the airflow is getting monitored, the incoming airflow as well as and how it is getting generated. So all this measurement needs an additional device, which is also needed to be enabled with the typical connectivity communication protocol uh, to the backend ERP or to the actual system for the analysis part. Um, that's what I'm going to talk about in the coming slides. Edge devices, I even slightly touched upon it. I'm going to talk about on the edge devices, which is typically will be on the automation area, and how this linkage is happening between the automation to the digitalization area, where you talk about services on the cloud, which is made available. In terms of the process, if you see in the production area or in the assembly area, we are talking about um, worker independent of assembly. Quite a lot of inputs have been taken in the standard process available with us, and it is being defined over there. And to the latest stage of even additive manufacturing, which is also going to be a futuristic production environment, and also going to be components which are going to be manufactured out of additive manufacturing, will also be part of this aerospace component manufacturing. SINUMERIK Edge, it's in simple words to talk about, it's connecting both the virtual world to the real world, and also define your actual data, define your process, define your design data, define your plan data, and also verify with the real-time environment what you are going to achieve it. So this is what we are going to see it over here. For this, we would need various devices in the manufacturing. One typical device, what I'm going to talk about here in the CNC one, is SINUMERIK CNC, uh, which is from the Siemens family of CNC control systems, which is directly enabled with Edge. Um, Two things in this is, one, on the user side, as an end user who's typically buying out a machine and then he's producing the components and also delivering to his customers, he would need a certain level of Industry 4.0 or digitalization set up into his factory, and he needs a certain monitoring parameters in his design area or in his process area, which is going to help him out into optimizing his uh, cost portion. So on that, there is one typical real-time device is for the CNC is SINUMERIK 1, which is a scalable, flexible, and the most powerful system, which we call it as a digitally native CNC. We can have the complete hardware onto a simulated platform, including the accessories which is required for it. So not only the controller, but also on the accessories part. You talk about the cables which is connecting the controllers to the drives, or uh, the drives to the motors, and there's a feedback which is coming from the motor to the back to the drives. So all those individual items or devices are edge enabled and also can be on a simulated platform. So in a production design, what happens is that people are trying to use NXCAD or NXCAM to design their component and also define the process to manufacture. They also define the extra elements like the jigs and fixtures, which is used for manufacturing that particular component. Those things were simulated onto a virtual area, and customers who are using it, they feel really good in using it, but it's not a full-fledged simulating platform. It doesn't get interlinked with the hardware, which is actually going to be the machine on the shop floor. So if a customer can be given an add-on input of the simulated hardware, which is going to be in his shop floor, interlinked with his process defined on a simulated platform, then he gets more or less, I would say, greater than 96% of data accuracy, which is actually going to be is ready to set up a production plant in the future on his project plan. This obviously will also help them out into optimizing their cost, optimizing their process in setting up of a manufacturing plant and process further on. This also enables them to define their requirements of accessories. They can pre-plan it and also bring it on to the same level of uh, uh, as soon as the hardware comes into their factory, they can immediately start production and deliver the results to the customers, their customers. So this is one typical hardware which I wanted to talk about here, SINUMERIK 1, which is on a virtual as well as on a real platform uh, in terms of the hardware one. Coming on to the performance side, the data out of these particular machine is also directly connected to the MindSphere. It's a Siemens platform for cloud services, and here not only the data which is available from the existing SINUMERIK 1 system. In a shop floor, you have various other machineries with different control systems. The data can also be enabled and captured onto MindSphere using either a Siemens-based app, which is dedicatedly created to capture these data points from the CNC controller system or the PLC system. But also you can also use a third party or you yourself if the OEM is preparing a data or an app which is capturing the data points from the machine, and those points can also talk on directly onto the cloud system, and that feedback can also be monitored and further on analyzed to define an optimal process further. That's one thing which we are going to talk about, and the SINUMERIK 1 is delivering um, the digital twin on the performance side as well. Two things on the SINUMERIK portfolio which I wanted to talk about here is on the combination of automation together with digitalization. In fact, one of the questions that they have a equipment which is pretty old. Today we are talking about Industry 4.0, And can that particular device, which is 10 years old, 15 years old, can it be connected? And also, uh, can it be can we create a digital twin of that particular product, as well as also the connectivity further on uh, uh, used for analysis part? Yes, there is a possibility to do all those activities only when we talk about an automation retrofitment or an existing device, as well as create a connecting protocol for the digitalization in your shop floor. Um, Talking about automation, this is the virtual and the real scenario. The virtual preparation of job, which is again defining your tools, defining your fixtures or jigs, which is used in the manufacturing. What is the material which is used? The material uh, characteristics. What is my process speeds and speed, which can be defined over here, and also more similarly you can calculate in the virtual environment what is my cycle time, or what is it going to be my production time in a virtual area. And we can also do a virtual training on all these areas, sitting at a in a cozy room and on a desktop or a laptop, and customer can experience this, and then further on he can uh, uh, work on the real environment. When we talk about the real environment, the CNC machines, the CNC controllers, or the PLC equipment, which is getting connected onto a shop floor into a complete manufacturing, uh, it is having various different protocols in the shop floor, where we see a PLC either from Siemens, which is Step 7 1500 integrated PLC together with the CNC system, or a third party PLC system used for various other activities, including the sensors or onto the tool management area. Uh, all these things can be virtually simulated and also brought into a real form of existence. We can also, in reality, we can see how the performance is going to happen on the machine, and you can monitor your process, whether my output, which is received out of the software, can I compare it and also virtually validate it before sending it onto the machine? Yes, that is possible. And even before the machine arrives in your shop floor, we can do a simulation, do a digital twin of your machine, be it a simple 3-axis machine or a 5-axis complex machine or a gear hobbing gear grinding machine. This could very well help you to do an analysis. What is my output of the software and what is my deliverables, which is going to be. And the last point is on the multi-core technology. This is talking about process optimization and in turn improvements of your productivity on the shop floor. There are process which is certainly defined based on your standards, standards defined by your customers, and based on that you are doing a process to do the production. There again, on the control side, we can do a definite optimization with your speeds and feeds, and also dependent on your materials, and you can uh, take care of uh, the production optimization area. This is on SINUMERIK 1. Secondly, the higher hardware which is required for automation on a complex machining is SINUMERIK 840, which is integrated with Step 7 300 PLC. There are support system within inbuilt in it. Uh, this this SINUMERIK 840 is using data capturing, it is inbuilt into it, and you can take as an output out of this particular controller using an OPC UA protocol, and the customer can get the data as he defines for his requirement, and then he can do the analytical part in order to optimize his process and machining. Next, today we are being facing in the industry death of uh, skilled manpower in terms of operations, which is very much a topic which we are also addressing it from the Siemens side as the support to industry. Um, robot, which was earlier used only for loading and unloading function. Today we are talking about robots used for machining activity as well, right from pick and place to loading and unloading, and also to manufacturing. So that's in manufacturing using robot is a concept which is prevalent, which is the highest point of automation. Um, Integrating two different CNC machines or multiple CNC machines, and also different process machines in the manufacturing line that can be integrated with the robots predominantly to do a pick and place loading and unloading function. The controller is also required to be more flexible in handling the robotic, and today's death of robotic operators requirement is going to be a futuristic requirement from most of the industries. To address that point as well, the controller is enabled with easy handling of a robotic. So the common interface between and the robot can be done using various protocols, either an Ethercat, Ethernet, or any protocol which is defined by the robotic manufacturers. The programming, you no need to have a different pendant as such, where you need to learn about robotic programming. But otherwise, directly the customer can do a program using the CNC and control the robot for his applications. So that's one point which is called as the SINUMERIK Run My Robot functionality, which is an high point automation required for today's industries, typically in aerospace and complex manufacturing. I was talking about bridging automation with digitalization. Yes, this point of digitalization, we are having MindSphere, which is a strong platform for having the cloud services for various devices. One particular module which is used for capturing the data from the machine tool is also a part of the machine tool module, which captures the data using OPC UA or directly using different softwares which can be connected onto the cloud system. Um, or the customer or OEMs can create an app by themselves using a different software background, either using Python or various other app creation, and that can also capture the data from the CNC controller on the machine tools in the shop floor area. Um, to maintain the accuracy of the data, which we are getting it out of the CNC controller, the devices, the more the devices what you're connected, the more the data input what you're giving it, the maximum positive result you will be getting it when you do the analysis part. The lesser data, the lesser analysis output you will be getting it. Um, that creates an absolute necessity for us edge device, which is required at every other element used on a machine. And one such edge device used in the machine tool area is SINUMERIK Edge, which is going to talk with the machine as well as onto the MindSphere uh, IoT operating system. This is on the CNC area, but if it is going to be on the PLC, it will be a nano box, what Ayyappan has mentioned in his presentation. That is a common IoT device which interlinks a PLC-based machine to the cloud platform. Edge applications typically required. I have cited out two different examples over here, which is part of this edge device and creating a step for entering into digitalization any customer who's having such kind of a CNC controller can use this particular feature. The critical point of monitoring in a real-time data which is required. So for that, there is something called as CAP monitor, the monitoring of machining of critical parts, and these edge devices are typically capturing those data in a real-time environment, and those real-time environment can also be frequency defined, and also on the complexity. Based on the complexity, you can define the frequency of data capturing data points into the edge devices. That's one thing. And in terms of the process, there's something called as analyze my workpiece capture, which does a very detailed analysis on your tool path definition, any errors in terms of the tool path. Typically, if you consider a blade has a quite unique design of their data, and that requires typical strategy which has to be followed for a blade machining. Depends on the material which is being used, depends on the tools which is being used, depends on the fixture which is supporting the blade to be machined. So all the data points can be fed in, and in a virtual environment, in a digital environment, you can do an analysis of the workpiece. How am I going to get an output? Virtually, you can get all the error points from this particular software. So this predominantly avoids a downtime, basically, correction time, which happens generally in a physical area or in a real-time area later when the machine arrives. So that's one point which is going to help the customers as you. Generally talking about industrial age, I was specific only on the CNC part in the last few slides, but here I'm going to talk about the complete hierarchy or the pyramid of manufacturing, IoT manufacturing, I would say. You talk about the field devices, right from field devices to the controllers, and you are operating a process using the software, and your MOM or MES system, which is getting onto the top layer below the cloud system. So this is how a typical manufacturing hierarchy looks like, where you have multiple devices in your factory on a line for manufacturing. Every other individual device is having different types of protocols, and that has to be connected to a common platform, and then further on the connectivity happens, the data point what you get it out, you can do a proper analysis for your optimization of the process. This typically happens onto which is predominantly required onto a complex and a highly technology oriented manufacturing like aerospace. uh, in certain automotive companies as well, these kind of mechanisms already existing in India. References are there in India and outside India with Siemens, which is already working successfully. We can also go in depth on the workflow, how exactly this industrial edge is going to work upon. This gives you a pretty good understanding for you. What are the kind of industrial edge which has to be managed, and what devices and apps which has to be developed. Cyber security is a big topic today uh, in a manufacturing environment, which is your intellectual property, and there you face a high challenge of your data. So there you should be very carefully on the cybersecurity, and these devices are enabled on when it is either connected premises or onto the cloud system. The safety and security is being integrated part of it. And even for the app creation, we have another software portfolio from Mendix, which helps in creating different kinds of apps. You can define certain parameters if you need only 10 different parameters for your manufacturing. then you can define those parameters into an app, and you can give a field there to capture those data in the app, and then you can get those data out of it. Industrial edge devices within the Siemens portfolio, we are with the CNC, the SINUMERIKs are the CNC, the SIMATIC or with the PLCs. We have the SCADA for the process automation area. We have the Step 7 1500 for the PLC devices. We also have these devices connected with the edge enabled protocol. So this will give all this data output, and there is no need of an additional device which will be required to connect to the cloud services or in-premise services. That's the one thing is an advantage when it's going to be on the Siemens product range. There could be a question on the older systems. Yes, definitely third-party device can be connected and your data can be extracted from those devices as well. And you can create those data exchange points within your factory premises or onto the cloud system. This is how the typical industry works upon. In specific to the machine tools, there is edge management device, SINUMERIK 1 or SINUMERIK 840D are edge enabled. Basically accessing and processing big data, which is used for analytics, and we can have a higher amount of efficiency of the data outputs depending on the edge devices which is connected onto your machines, and those data which is going to help the customers to get a proper output for doing the analytical part as well. You can start at any given point of time on your shop floor. It is not that you need to have it at the very beginning in the planning stage, but also as a brownfield, if I consider there also you can start integrating these kind of edge devices, or you can also do a custom-based app for your machine based on the technology what you have it. For those were the points where for both end customers as well as the machine manufacturers. When it comes down to the machine manufacturers, then it comes down to different types of coding system or the IoT devices, what they already have it today, and whether those things can be integrated with the edge devices in the shop floor. Yes, that can be part of it. The functionalities and the protocols can help them out to reach out in getting them optimized data output from their devices. Remote management, it's typically required for a machine builder. A simple CNC machine with 5-axis capability goes and sits out at different remote corners in the part of the country, and they cannot send across people for each and every small requirement from the end customer. They can start doing this remote management of their machines using a software update. They can do it remotely from the existing location. They can, to an extent, they can also do a monitoring of their machine individually and give a data to the end customer saying that, okay, this is my motor efficiency parameter. Right from day 1 to day 100, this is my motor data efficiency, and it shows a graph typically how does it actually function. So with that data, the end customer can plan for his preventive maintenance, or rather, he's been given a predictive analytic information so that he can optimally plan the shutdown time and do a preventive maintenance at a shop floor. That's good. That's a big advantage as builders, machine builders has it, and also access to the machine data. The OEMs are given the remote access to the machine data. With that data, they can create different business models, and based on the data points, they can work out a typical business model for their business. A perfect integration of automation and digitalization is creating a connectivity between the shop floor and the top floor, what we generally say it as. And yeah, so it's not limited only onto our Siemens Edge devices, and you can also see the process and Edge integrates all different third-party devices, which is prevalent in the industry today. Typically, on this is on the digital twin, and which would be required on a complex manufacturing of aerospace manufacturing area. To experience all these things, we also have given you a platform to gain that particular experience. Is our digital experience and application center located in Bangalore. Just uh, a few things about this particular center. This is one of such kind center which is present in India. The other 7 centers are present in Europe and other parts of Asia. Here we do have the CNC equipments in our shop floor. We do have a training environment created for people to come and experience it. We also have a demo experience on the manufacturing digital twin on the design, the product, as well as on the performance is being showcased practically over there. So I would like to invite the audience in the call to also come and then experience and have a look on practically visually seeing is believing. So you can have a look on this particular facility what we have it at Penia, Bangalore. And further to it, we also do various other training programs for people to get enabled to the latest technologies, including Industry 4.0 enabled or to high-end robotic and CNC programming. We are doing at this particular center, and there's a link over there mentioned over here in the center of the center bottom of the slide. There you can find a link which will take you across to registration, and further on you can come and gain the experience and of this digitalization arena what we have it here in India by Siemens. Typically, other than that, as Mr. Mauli has said, we have the factory in Kalwa, which is practically working on that's a switchgear factory where we can do it have an experience on the digitalization created on the assembly area for the switchgears that's present in our Kalwa, and that's the Siemens principle is like we ourselves are manufacturers, and we experience the effect of digitalization and we demonstrate it to our customers into various fields. That's all from my side, and thank you for your patience. Over to you, Mr. Mowley. Over to you, sir. Mr. Mowley, you are not audible. Still not.
Am I audible now?
Yeah.
Oh, no. Not audible.
Again.
for me. Ayepan sir. Okay.
So we can't hear you.
But meanwhile, don't wait for me.
Okay. I think we put it on the chat window. Please proceed with Q&A. Shankar, I think maybe you can take it from last. Is the digital application center from Siemens can be visited virtually? So you can answer the question.
Yes, Mr. Subramaniam. Yes, you can view it virtually. You can have a look on what are the machineries present, and you can access to that particular data. We can share the link to you.
Yeah, thank you, Shankar. And I think you whatever the link you have registration mail you have given, no, there we
Yes.
have to get registered, no.
You get registered in that particular. If you open that particular link, you will have all the data in a stationary format. You will have it. It's not a dynamic area; it's a static area where you will have the basic content. What are the courses being introduced over there? Who's the contact person and the schedules for the coming months? It's being released over there. And what is it available as a basic infrastructure is you can see it as a photographs. But if you want to have a digital twin of how exactly it looks like, we can also share that link once you get
Yes, sir.
registered.
Am I audible now?
Thank you.
Ayepan, am I
Yeah.
audible?
Yes, sir, you're audible.
Yes, now.
I don't know. I just re-logged in. Yes, please go ahead with the Q&A. I don't want to interrupt. Continue.
So, Mr. Balasubramanian, hope I have answered your query. And
Thank you, Mr. Shankar Narayan. I will register and then proceed as per that.
yeah. So, Mr.
Mr.
Maulik himself
Balasubramanian
has
is from
posted a
Toyota,
question.
correct?
Yes, sir. I am from Toyota.
Yes, very good, sir. One question related to that I have, Shankar.
Yeah.
We would like to do from January onwards, we want to do 2-hour masterclass, immersive training, online basis. It could be Bangalore Chamber of Commerce, it could be other forums. Is Siemens ready for online training? Not only a webinar, but training, immersive training where we will only take 10 to 12 people, but they will go through a very rigorous training.
Definitely, we can work it out the modalities.
Theory and practice.
Yeah, so practical is always a point. On the software area, we can give there is certain limitations where we cannot go beyond a certain point in giving the practical experience, the look and feel. We can definitely do a session. We can work on the modalities and we can define the number of days and how do we go this forward. We can do that.
For example, simulation-based training. There are simulation softwares, training softwares are available. I'm sure Siemens is doing it internationally. You might like to talk to your headquarters or to Bombay. It could be any area. It need not be only digital twin. It could be even your fundamentals of automation. I know Sachin Banshali has got a host of courses. If you are able to do some of them online, theory, let's say 50% theory, 50% practical, that will be welcome as master class on a paid basis. And many institutions are looking for such programs conducted by a global leader like Siemens. We'll talk offline on this, but I just thought I'll mention it on behalf of our participants also.
Okay, we also have the CAD and the CAM software or the digital twin requires certain software expertise.
Whatever is available on an e-learning, what we call the e-learning, online theory and practical, with assessment and certification.
Sure. We can work on the modalities and we can do that.
What are the other questions in the text box? Ayepan sir?
There is one question asking about Wonderful transformation. What is the level of e-security which can secure this remote machine management? What if
Yeah,
somebody hacks and misguides a machine?
please go ahead.
Yeah, so Ayyappan, you want to take up that?
Sure, you go ahead and I can add up.
Yeah. Okay, so the level of securities, the cyber security is a very key point. When we talk about, when we showcased, you can have the machines connected either in the in-premise solution or on the cloud system. Even in the cloud system, you would be defined with an individual area allocated for you with a separate access points. It would be a access points only for a proprietor, what data point he requires, and with his limit of access, he can only access to that particular point. So the security point of thing is very much valid. The machine management, which we need to protect it. If we open it up the controller on the machine, then it is an easy point to anybody to misguide it or do some malfunction in it. The user-defined profiles can be enabled onto the system, and based on that, the level of access would be provided. And that's the basic system. Ayyappan, you want to add further?
No, I think that's that. See, the multiple levels of this can be done. In fact, that could be a audit as well as the levels of the openness and the transactions what are required. So there is also a e-security audit we can go through and then have recommendations based on the kind of transactions that we need to have.
Okay, thank you.
So I saw Mr. Ayyappan, you have posted the Sansera case study.
Yes.
So we can go into the website and see the case study, right?
Yes, the link is there. The details of the case study are there. Contact person is Mr. P. Mahadeva, and the engineer who did this simulation is a person by name Mr. Sujit Nath. So both are.
Is it in the automotive connecting rod business or the aerospace business?
The started was with the automotive business. I'm sure they are expanding across to other businesses as well. So.
Very good, very good. One question I have for Shankar. In maintenance, repairs and overhaul, does your digital twin or simulation have any solutions to manage the maintenance, repairs and overhaul industry of aeronautical industry?
Yes, I think Ayyappan touched on the point of VR and AR, which is going to be a very much a valid tool in MRO industry today. Leave about the manufacturing on the assembly area or to identify a problem itself on an existing product, which is an aircraft or individual components within the aircraft. So we need to first of all do an analysis part, first through a visual analysis, one, and secondly through a data point which can be captured from those existing devices, and then we can do a correction of that. Certainly, yes, we do have it. The digital twin for MRO is already available. And even onto the assembly stage is also typically available. In one of my slides, I've also shown a virtual simulation on that on the assembly area as well.
For Aerospace Aviation Skill Council, which was founded by Bangalore Chamber of Industry and Commerce along with CRT and HAL, we would like to do an exclusive webinar for MRO industry.
Okay.
Our good friend Mr. Arunakar Mishra has joined us today's webinar. He is a committee chairman of Aerospace Council of BCIC. I'll request him whether we can do a joint program on the MRO side of the simulation from Siemens. We'll work on it separately. Other question I have for Mr. Ayyappan.
Yes, sir.
The Corona regime, to what extent it has accelerated digital twin adaptation in Indian industry, not only global industry, but Indian industry. Can you cite some examples?
Okay. In fact, very, very high. In fact, if you look at the recent number of people who have won the startups, and specifically, I can take some of the EV startup. A lot of them are in Bangalore. So the attraction towards the digital twin has accelerated very high with all these startups in place. Now that they are able to connect, create, and get this digital twin as a vehicle for their both product development as well as product introduction into the market. So that is a case in point, and there are quite a number of people that we have done. Including there are at least a few people in Bangalore as well. I may not be able to tell their names, but all are popular names. In fact, as we speak, there is also one more from the EV and the startup side of it. Pune-based again is on the discussion the digital twin, and how do we use the digital twin for launching their products faster into the market. So this acceleration has been very high, specifically for the startups and the EV business, I would say.
Great, great. I'm not only talking about startups. Coming to the MSMEs, are there any typical case study where the return on investment payback is worth it? The investment for digital twin kind of concepts, and can you quote some case study in India, Mr. Ayyappan?
Okay, so
small enterprises below 50 crore turnover kind of.
Okay, again, the digital twin is very wide, and if you look at I would say the three sides of it, both the product side of it and the tool design side of it has been very popular. So the tool design and manufacturing has been more mature, I would say. What he actually like done to one of the customer here, he's there in Chennai. He is in food and beverage business. So yeah, food and beverage business, and the essence for them to become competitive, because the players are very big, and he would like to get into this competitive market. So what this customer he has done is to take this digital twin for the formulation process. Formulation process as well as the laboratory information management process, and for the kind of size they are in, they put in a significant investment, because they were able to see that they've been doing that evaluation with us for more than a year, and they could see that significant benefits and the importance of having this digital twin to be a competitive advantage. So it is not merely about an ROI, but for them it is becoming the competitive differentiator and business advantage.
In which sense, quality or productivity or throughput time?
It is for the new product introduction. So it is for the innovation product and quality. Launch. Yeah, product launch.
In food and beverage industry, product launch enabled by your system, your concept.
Yes.
That's fantastic. Shankar, how many legacy machines are now IoT enabled in the Indian CNC population of Siemens? Number one, can non-Siemens control also can be IoT enabled? If so, what is the typical budget range per vertical machining center or horizontal machining center of old control systems? I don't want you to say it all depends. I want to give you some number.
Okay, so that's a good question.
That is a popular question in many forums, so I want to use this opportunity to catch you on this.
That's a very good question, sir. I would address the second point in the question. Second question, I would say, I'll start with the second question. Can non-Siemens be IoT enabled? Yes, yes. So as Siemens, we do take up a digitalization project directly within Siemens portfolio, legacy product of Siemens portfolio, as well as non-Siemens portfolio. So that we definitely do it. How do we do it? There are challenges in legacy products. Those days, Industry 4.0 or the kind of requirement what we have it today were not the expectations from a customer during those days. And typically, a lot of things were managed with, I would say, pen and paper, then onto the Excel sheets and Word documents or presentations, what it comes upon. So there are certain requirements which comes on the working of connecting those legacy products. There would be certain hardwares which would be required which has to talk to the legacy products. Yes, it is possible that we do have certain examples and references in our within India. You can consider within Bangalore or Chennai or pan India, anywhere in India, we have references connecting machines on the cloud system, either within the factory or onto the cloud system. So some customers still don't want their data to go onto a cloud, though the cloud is an individualized access. Still, they have a worriness about the security part. So they wanted to have it within their premises. That is also very much possible.
Right. I'm not really looking only cloud. It could be on-premise solution. What is the approximate budget per unit machine?
That depends on what level of access. I can start with the price of a cup of coffee.
You would love to do that? Okay. I think it's a very diplomatic answer. Okay, Mr. Ayyappan, what is the fundamental difference, if any, between simulation technologies and digital twin technologies, if any?
Okay. So the simulation technology, very nice question, and it really opens up a lot of discussion, because there's a huge confusion among this. So what is a digital twin? For years we have a representation of geometry as a 3D CAD has been there for a lot of years. Now that is what some people may call it, not as a digital twin, but a digital shape. Okay. And the second side of it is now you add the behavior, the performance of it. Then you have one level of improvement, where you are able to simulate the behavior of the physical side of it. But when it comes to a digital twin, where you are able to connect the physical side of it and able to take back the information from the physical side to the digital side, where the continuous loop happens. And that's basically a big difference between the the simulation software. So when you look at a simulation, it is more only from a predictive side of it, and also only from a a specific simulation, maybe a CFD or a multidiscipline simulation or a 1D simulation aspects of it. Now, in a digital twin, what you're able to do is not limited to that. It may be for example, it may be electrical and electronics. So how are you going to simulate the software aspects of it? You are looking at from a manufacturing side, the quality side. So various aspects of it comes into a digital twin, and importantly, how are you going to synchronize this digital with the information coming in from the physical side of it, the connectivity side of it from the physical model, either product or a machine or a plant, and you are able to run as a cyber physical system. And that is where the digital twin is different from a simulation software.
In other words, what you're saying is simulation could be a one-way traffic, whereas digital twin has got a feedback loop between the physical and back to the physical to the virtual, whereas simulation is virtual to physical and then you wait for results. I mean, in a very generic sense.
Digital and a simulation is one component of the digital twin. So digital twin has a lot of things, and it includes the digital simulation. So it is only one component. There are various other aspects.
Very nice way of putting. In a master class, I would like you to explain later on what are those other elements of digital twin. It's a more like a theory kind of thing, because master classes are attended by students and people finishing school, and very ignorant people, including Chandramouli. So please consider a very fundamental approach to the concept of digital twin in those master classes. I think Mr. Upare is asking the same question I asked some time back. Is possible to connect conventional machines available in shop floor with IoT enabled? Yes, Mr. Upare. I think you joined a little late now. Only 10 minutes back, same question was answered. They could connect it not only from a Siemens machine control, but also from the non-Siemens control. And it has been proven in the Indian market. Mr. Shankar Narayan talked about a couple of hardware devices which were introduced by Siemens. And maybe you can put a link text in the text box, a link of those things, Siemens 1 or Siemens whatever, you call it. And then people can pick up the link from the text box. And remember, all these records also, recordings are going to the registered people. So those who missed it, they can see the link in the text. It's a very popular question. Can we convert legacy machine, IoT, etc.? Another question, which is earlier also asked, I think it was missed out. What is the accuracy between the simulation and the final result in your experience? Somewhere Shankar was talking about some 94%. So a little worrying because we cannot allow a 6% error when it comes to aircraft manufacturing or medical industry where human beings are directly affected. If it is automobile industry, okay, we can park the car and get down and have a coffee and start again. But in aircraft and in medical industry, you can't have a surgery going on and suddenly the digital twin has failed. So we don't know whether to cut open the heart or the lungs. Or in the case of aircraft, one engine is suddenly failed and the other one is working. And we have to find the nearest airport to land. So these are real life issues. So there is a question by Manish Shrikant Chaudhary and another person earlier. How are we ensuring validation of the equipment with the digital twins? And a previous question talked about accuracy and consistency between virtual and digital. In spite of the feedback loop, how much is a possible error due to latency and other challenges?
So if I can put my thoughts. So the accuracy, the physical side of it and the digital side of it is how close is the digital twin to the physical aspects of it, and that is possible only when you have when you are able to connect it across, and that is the reason why the connection becomes important. And the second aspect of it is, again taking in from the aerospace and the space scenarios, how close you are able to connect it across with the test facilities. So the simulation and test correlation between the systems and system of systems gives a good correlation to have the predictability, and how close we are is depending on how close we are able to calibrate it. Okay. And the level at which we can do it more, you are able to cover all the aspects of the risks inside. I think more closer we are. Whether 99, 99.8, 99.9 is something the level where what are the different other aspects of failures we are able to imagine, and then ability to look at the simulation and the data to connect and correlate these information. So important aspect is that is a journey, and important is you connect both the field information as well as test information so that the digital is more rich and you have a high fidelity simulation.
Fidelity is the underlining word. Thank you very much. Mr. Balasubramaniam, I think again from Toyota, is asking, can we diagnose metal cutting behavior? Is a very generic point. I am sure behavior, what he means, perhaps cycle time, surface finish, quality, so many things. Metal cutting behavior using digital twin. Though the variables are many, basically a postmortem for a tool failure or a process defect. He is asking. Go ahead, Mr. Shankar.
Yeah. So yes, for diagnosing metal cutting behavior, quite a lot of parameters, which is depending on verifying that behavioral pattern. One, be it physical or even in the virtual environment. In a virtual environment, let me talk on to the real environment. What we have it on the controller aspect. Whenever the program is fed in onto the CNC controller, we do have a simulation of that particular tool path, which is going to tell about where the errors are happening in the tool path during machining. Based on that, the customer can correct, the operator can use a correction, either it on the machine directly, or you can also send it back to the design department or the planning department who's doing this activity. That is one. In a digital area, how well we can do this? Yes, we do have the software which I've already shown across, like Analyze My Workpiece, which is helping the customer to virtually see it where the errors are being happening over there. So before entering into the actual production area, so he can do that simulation verification. That is one. Cycle time verification, it's already being done. It's happening for ages, which is being done with the production area with the CNC control systems. And yeah, so this is how it depends. And on the surface area measurement, various other factors depends. Today, even we talk about toolings which is being used in the surface machining. You also talk on to an extent of coolant which is going to be used onto it, so that the metal which is being cut and the chips which is not getting tangled with each other onto the tool or lying on the job surface itself, which is again creating a surface finish issue. So a lot of things, even a coolant to an extent is also going to be a factor which is going to define the surface finish measurement.
So I think Mr. Balasubramanian's question is, can turnkey operation can be simulated? That seemed to be the fundamental question. So if an application engineer can put his mind together, and to what extent sensor devices can be enabled or deployed in a turnkey operation, which includes even the fixture rigidity, cutting tool, wear and tear. So many parameters are coming in picture. Maybe you can have an offline demo for Mr. Balasubramanian, or if they are working, the factory is working, you can fix up appointment and explain to him in person. And along with his application engineers, he can go through in great detail. Similar question has come from Bhagat Singh Patil. And Shankar and Apan, you can type your email ID on the text box. So now it's almost 1 o'clock, we are through. And one last question, with which I would like to close, is a very important question by Mr. Chaudhary. I am sure he is from aerospace industry. Does digital twin is validated by regulatory requirements, or what standard is used for reference? For example, DGCA or the similar European IATA kind of regulatory. Are they clearing the digital twin as part of the process being approved by the aeronautical industry? That will be the last question. Other questions can be written directly to Mr. Ayyappan and Shankar. And this is only my last question. 1 o'clock already. We are supposed to do a hard stop at 1 o'clock. And after that, I will do the vote of thanks, or Rupa will do the vote of thanks.
Sure, sir. I think the lot of regulatory for the aerospace defense, as well as the for the food and beverage and medical devices, lot of regulatory they are accepting, as well as they are also auditing the process. So in the electronic process of compliance related, and in fact. The airworthiness ERP 4761, or for any of the other the test related regulations, as well as for the automotive, there is also the ISO 26262 regulation. So many compliance related regulations has become mandatory, and today it is becoming not possible to do that without a digital twin possibility. In fact, a case in point is the autonomous vehicles. If you look at the testing, so SCA classifies as level 1, 2, 3, 4, 5 from the ADAS to a completely autonomous vehicle, and it has to go through lakhs and lakhs of kilometers before before this vehicle can be put on road. And how do you do that is the only mechanism we have is the digital twin to run this autonomous vehicle into the conditions, different road conditions, with the pedestrian, with the climate conditions, and the weather conditions, and so on, to identify whether it is a pedestrian or a stone or a animal or an object. So the compliance and authorities are open, and now we are at a point where the digital twin has become a prominent part of the compliance aspect, not only to certify, but also as a part of a continuous validation and certification. So digital twin has.
In other words, what you're saying, Sayapan, is the good news is regulatory authorities are well accepting the digital twin as a concept, and of course they will go through many exercises to ensure that the validation is real life and it doesn't cause any other safety problem to the people in any industry, for that matter, medical, aeronautical being the most critical, those
Yes.
other industries as well. And Shankar is writing something about adaptive control monitoring. of course, yeah, which is very, very important in MRO industry. Adaptive control is very popular in MRO industry, especially repairing of blades, blisks, impellers, and so many things. On that note, we will close this conversation and we will do that MRO kind of program in another day, another time. And thank you so much for offering your valuable time on a working day, Mr. Ayappan Ramurthy and Mr. Shankar Narayanan, and coming two great Siemens management into on the one day is not easy. I thank BCIC to provide the platform, and I think we have around 70 plus audience today. Some of them left somewhere in between. That's okay, but recorded link is available, and Rupa will share it through the YouTube. And I think there is also a plan to put up all of them into what is called the BCIC website. So people can, it is a library, and they are going to allot a password for the BCIC members. So those who are not non-members who are there would like to note this point. And if you want a password to access the past records, you have to become a BCIC member. And those who are attending online, there is a package deal by BCIC. I don't want to mention the number. It's very, very nominal. And if you put that nominal amount upfront, you can attend any number of programs during a financial year. On that note, I thank once again Ramurthy, Ayappan, Shankar Narayanan, and Rupa for supporting this program. Thank you so much.
Thank you. Thank you so much.
Have a nice lunch.
Thanks.
Bye-bye.
Thanks a lot, Shankar.